Hello, Charger family. This is Mrs. Boyd at Mrs. Boyd's Math Room. Today, we're going to be talking about congruent triangles. It's going to be amazing. So, congruent means these are geometric figures that have exactly the same shape and same size. Okay? Congruent polygons tells us that all parts of one polygon are congruent to all corresponding parts of the other polygon. That is really awful, and I'm so sorry. That means angles and sides. So everything about the polygons are the same if they're congruent. So we want to identify all congruent corresponding parts, then write a congruence statement. All these dashes along the sides and the different number of arcs in the angle are going to tell us what's congruent. So first we're going to look at congruent angles. Well, we know that angle A is congruent to whatever has one rainbow on the other polygon, which is angle E. We know that angle B has two arcs and it's congruent to angle F, also has two arcs. Angle C is congruent to three arcs and three arcs, angle G. And last, angle D, which has four arcs, is congruent to angle H. Now we're going to talk about the sides. One dash is between segment AB, and that's congruent to segment EF, also one dash. Pause here and fill the rest of this out yourself. Segment BC is congruent to segment FG. Segment DC is congruent to segment GH. And segment AD is congruent to segment HE. Final congruence statement. ABCD, polygon ABCD, is congruent to, now here's the tricky part. We have to put the vertices in the same order on the congruent polygon as we have them in the initial polygon. So if the initial one's A, B, C, D, the second one has to be E, F, G, H to show that what parts of those are congruent. There you go. All the angles are congruent. All the sides are congruent. That means the polygons themselves are also congruent. In the diagram, triangle ABC is congruent to triangle MNO. Find the values of X and Y. Well, since AC is congruent to segment MO, because those are in the same place in the triangle. AC is the two ends, MO, two ends. That's supposed to say since, not sin, holy moly. Then the measure of segment AC is equal to the measure of segment MO. So we know that 32, which is AC, is going to equal 5y minus 12. So now I can solve for y. Add 12 to each side. And that's 44 equals 5y. Divide by 5, and y is 44 over 5. Also, for the angle, for x, since angle B, which is in the center, is congruent to angle N, also in the center, the measure of angle B is equal to the measure of angle N. So we can say 2x minus y equals 90. We also know x. I'm going to turn x or y into a decimal for this and call it 8.8. So 2 times, that's y, not x. 2x minus 8.8 equals 90. We add that 8.8 to each side. I'm going to move up here. 2x equals 98.8. That means x equals 49.4. Yeah, the order that you write the congruent statements in matters a lot. So be sure to be very careful when you write those. Flip your paper over and let's talk first about the third angle theorem. That says, it's kind of long, bear with me. If two triangles have two corresponding angles that are congruent, then the third angle of each triangle must also be congruent to each other. Whew, that's a long one. CPCTC is a little acronym here I've given you, and that stands for corresponding, I'm so sorry, not congruent. Parts of congruent triangles are congruent. So let's put this into practice. We're given that angle V is congruent to angle Z. Segment VW is congruent to YZ. Segment VX is congruent to ZX. And segment WX is congruent to XY or YX. So we want to prove, beyond a shadow of a doubt, that triangle VWX is congruent to triangle ZYX. Well, our first statement is always going to be what we're given. Angle V is congruent to angle Z. Segment VW is congruent to segment ZY. Segment VX is congruent to segment ZX. Segment WX is congruent to segment YX. And that is given. Next, well, let's think about the other angles that we don't know about. We don't know about VWX or ZYX. We don't know about VXW or ZXY. That's going to probably be the easiest one for us to start with because those have a special name. We know that angle VXW is congruent to angle ZXY because it's the vertical angle theorem. Vertical angles are congruent. We know those are congruent. Now let's look at the next angle, the only part of these two triangles that we don't know. We know V, that's a W. Excuse me, VWX is congruent to angle ZYX. I want you to notice something before I write the reason. I put VWX because I know V and Z are the congruent points on each triangle. So V are there's the similar points. VWX, and then I'll say ZYX because those are the points that are congruent in that order. Those are congruent because we just talked about the third angle theorem. So that tells us triangle VWX is congruent to triangle ZYX because corresponding parts of congruent triangles are congruent. Ta-da! One more, a lot like that, another proof. We have angle J is congruent to angle P. Segment JK is congruent to segment PM. Segment JL is congruent to segment PL. And L bisects KM. That means those two are also the same. Prove triangle JLK is congruent to triangle PLM. Like we did before, we start off with the given statement. So angle J is congruent to angle P. Segment JK is congruent to segment PM. Segment JL is congruent to segment PL. And L bisects segment KM because given. Now, let's think about things that we don't know quite yet. We don't know angle JLK. So it's easy to start with vertical angles because they're easy to see. So we know angle JLK is congruent to angle PLM because the vertical angle theorem. So JLK and PLM. Next angle we don't know about. Well, I marked something on our triangles that we don't really know yet. So let's prove it here. All we were told was that L bisects KM, segment KM. So I know that LK is congruent to LM, segment LM, because it's the definition of a segment bisector. I assumed that we knew that, and we didn't. We weren't explicitly told that. We were just said that it bisects. One more angle that we need to talk about, angle K, has got to be congruent to angle M. Those are the only two angles we don't know about because the third angle theorem. Finally, we can say that triangle JLK is congruent to triangle PLM because congruent parts of congruent triangles are congruent. I hope these make sense to you. It just takes some getting used to having to justify each step. I'm happy to help if you need me. You know how to reach out and get a hold of me if I can help in any way. And I really hope to see you soon.